today our group members going to present about laser-induced breakdown spectroscopy. Hi, my name is Natasha. My metric number 192829.
Hi, my name is Shafinas, metric number 192820.
Hi, my name is Raida. My metric number 194787.
So let's begin for our presentation. So my first slide is about introduction. What is laser-induced breakdown spectroscopy, as known as LIBS? So for the first point, a rapid chemical analysis technology that use a short laser pulse to create a microplasma on the surface. The second point, a pulse laser focused down to the high intensity spot on the material. So can you guys imagine how LIBS in structure?
Yes.
Okay, it can be LBS, it can be configuration for both the laboratory environment or in the fields. So, for versatile sampling protocol that include fast rater of the sample, surface and deep profiling. For LIBS example sample is we can use a metal, semiconductor, glasses, biologists, insulator, plants, soil and electronic materials. So do you guys get it?
Very clear.
Okay. So next, this is a example of instrumental design structure. So we got the pulse laser through the mirror and mirror pass to the focusing lens, and then focusing lens plasma plump gonna be uh, emit to samples, and then collection lens to the spectrometer, and then last detector array. So let me explain more detail about the characteristic of instrumental design here. So for the first one, the pulse laser at midlight, which consists of discrete line bands overlying continuum. So continuum is something like chain in slightly stage. So in this structure, we got a step by step. The second point, discrete line character should be have a three features, which mean wavelength, intensity, and shape. So the impingement radiant energy of the pulse must be higher than the breakdown energy for the sample, which means the pulse laser should be higher than everything. So mirror that we use, rear mirror, and the mirror function for reflect the light from the laser to focusing line. So focusing line, the most common lens used to focus laser pulse have diameter of 20 to 20 or 15 millimeter and focal length between 50 and 150 millimeter. So material of the lens should have a maximum transmission at the laser wavelength, and there must be contact with anti-reflection layer to the minimize transmission laser. Okay, do you guys know why we should use a maximum transmission?
No, why?
Because a laser beam can lose energy, can lose around 80% of its energy passing through a contact lens.
Oh, okay.
Okay. So next is plasma plump. When the laser is discharged, it will focus on the form of plasma, which atomize an excited sample. So, and the formation of plasma only begin when the focus laser achieve a certain threshold of optical breakdown. This happen when should be in high temperature, right?
Okay. Yes.
Okay. As I said before, for the first slide introduction, the sample that we can use is a metal, semiconductor, glass, biological tissue, insulator, plants, and solid and electronic material. We can use either solid or liquid. Okay, for the collection lens, okay, let's previous slide. Okay, this is a collection lens. Okay, we got the primary, secondary. Okay, so collection lens, the first lens collimates the emitted line to improve the focalization of the second one into the fiber
Probe.
fiber probe and to optimize the ratio of the required light. So, do you guys understand about the the collection lens.
Yes.
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 Okay.
Yeah. So next, spectrometer. So spectrometer consists either a monochromator, we call it no scanning, or a polychromator, no scanning. But most common use in our instrumental structure, we use polychromator spectrometer because it allows in simultaneous acquisition of the entire wavelength range of interest. My members group gonna be present more about the spectrometer, how it's working. Okay, so
Okay.
detector array, the last one, the last part, detector array have a different kind of detector which is depending of the application. So detector, the means of this means detector have a kind of different application, and have a different types. What we call the use of the detector array. And if to measure light intensity without spectral decomposition, can use the photo multiplier tube, or we call PMT, and a valence photodiode, or we call APD. But the most common device that we use in our instrumental structure is CCD. Oh, what CCD? Okay.
Okay.
I think you guys understand, right?
Yes.
Shafinas will explain more detail about how the principle working, right, Shafinas?
Yep.
Okay.
Okay. So
Then,
I will proceed on the working principle of LIBS system. So,
okay.
wait. Okay.
Okay.
So, Natasha just explained about the instrumental design, but the question is, how does the system work by using all those instruments? Okay.
Yeah.
Generally, uh, LIBS system consists of pulse laser. This, can you guys see? Pulse
Yes.
laser. Okay, so it is very highly focused.
Mm.
Okay, so this laser is fired at a sample. So this sample can be any sample such as powder. So we can use powder as a sample. Okay, and then it will create a plume of plasma.
Mm-hmm.
After it is being fired at the sample, a plasma plume is formed. Uh, a plume of plasma is like a fluid which is consists of gas and liquid.
Yes, I see.
So this plume of plasma consists of electronically excited atoms and ions. So as we all know, when atoms or ion is being pumped into an excited state, it will fall back to the ground state, right?
Yeah.
So as these atoms decay back into their ground state,
Yes.
they will emit characteristic wavelength. So generally, that is how LIBS works. Okay, let's go deeper. This pulse laser consists of 5 until 6 microjoule per pulse energy range, and it is pulsing at 50 hertz.
Okay.
The laser passes through a focusing lens to focus the laser beam down to approximately a 50 micrometer diameter. Just like Natasha explained just now about the characteristic of the lens. So
Mm.
the pulse duration is 1 until 2 nanosecond, which is billions of a second. It is very fast. Thus, it will need a high enough power density. The energy is very high and the time is very fast to vaporize the material producing a plasma. Okay, and then we need to let the plasma cool first. Okay, just now after the plasma plume is formed, we need to let them cool first. As the plasma cool cycles over a few hundred microseconds, the electrons that were stripped from the atom, they will recombine back with the atom. And that is how the light is being emitted after the atoms recombine back. So it will emit light in UV, optical and also infrared. Okay, the emitted light is picked up by lens, which is collection lens. It will collect all the emitted light and then focus onto a detector such as CCD. So the spectrum of the emitted light is then analyzed. So the spectrum, which means the band of colors. The band of colors will be analyzed for the presence of atomic emission. So we can know which element are present. From the color, usually we know, right, the wavelength of the light. So we can determine this wavelength is what color, this wavelength is what color, right? So based on this process, that is how we can determine which element are present in our sample just now, such as powder. Okay, and on-board spectrometer analyze the emitted light by measuring the wavelength and intensity of the specific wavelength. That's why the wavelengths are very important. Why we need to know the wavelength, because we want to know what element. Okay, next we also use software to compare the spectral lines. Spectral lines mean visible region or dark or bright line. So other than that, we also use on-board calibration to quantify the concentration of the element. We want to know the concentration of element. We want to know the characteristic of the element. So we can use on-board calibration by knowing the intensity of those lines. So we can determine the concentration of the element. Okay, the physics concept of on LIBS. So a typical LIBS system consists of NDX, solid state laser and spectrometer with a wide spectral range and high sensitivity, fast response rate and time gated detector. So we have a solid state laser, spectrometer and also detector. So this NDX stands for neodymium doped yttrium aluminum garnet, and laser is an acronym for light amplification by stimulated emission of radiation. So basically LIBS involves the process of stimulated emission of radiation. So the NDX laser, it can generate energy in the near infrared region, which is the wavelength is 1064 nanometer. The pulse duration is in the region of 10 nanosecond, generate a power density which can exceed 1 gigawatt per centimeter squared. So the power density is very high. Like I said just now, the energy is also high. The time taken is also faster because the laser is a short pulse laser. It is very fast. Okay, other than that, we also use excimer, which is excited diamond type of laser. It can generate energy in visible and UV region. So visible region is between UV and infrared. Okay, the spectrometer. Okay, other than that, the physics concept that is being applied in LIBS is EM radiation. Okay, the spectrometer is being used to collect EM radiation over the widest wavelength. It also can maximize the number of emission lines detected for each particular element. Okay, the spectrometer response is typically from 1100 nanometer, which is near infrared, to 170 nanometer, which is deep UV light. So the response of spectrometer is approximate to the response range of CCD detector. So that is why we use both of them. We use spectrometer and then we use CCD detector because they have something in common. The response is both of the response are approximate. Okay, let's talk about energy resolution of the spectrometer. So when we have high resolution system, we can separate spectral emissions line in close juxtaposition. It means comparison. When we separate the spectral emission, as shown in the figure just now, when we separate the band of color, we can make a comparison. This color stands for what? This wavelength stands for what? So, it also can reduce when we have high resolution. It can reduce interference and increase selectivity. So why do we need to know the energy resolution of spectrometer? This feature is particularly important in specimens which have a complex matrix. For example, when we have a sample with a large number of different element. Accompanying the spectrometer and detector, we also have delay generator. So the function of delay generator is to get the detector's response time. We want to know the amount of time needed to acquire data for exact same location. So that's the meaning of temporal resolution. We want to know the time needed to acquire data. So basically LIBS is an entirely optical technique. So it uses light to probe or control matter. So this is of one of major significance as fiber optics. It is also use light to send information, right? Fiber optics.
Yeah.
So it is also used for remote analysis. So that's one of the importance of LIBS system. Okay, I will pass to Haida. She will explain about the application of LIBS system.
Okay, LIBS in biomedical application. So LIBS can use in biomedical application to analyze chemical composition of biological samples such as human bones, tissue, and fluid. And then it also can help to detect excess or deficiency of minerals in tissue, teeth, nails, or bone, as well as toxic elements. Okay, so next, it can detect cancer, and it can provide a surgical device which can detect and destroy tumor cells at the same time. Okay, so next, LIBS also can use to classify pathogenic bacteria and virus. Okay, so last, in biomedical application also, LIBS can use to provide a fast analysis tool with easy sample preparation, for instance, in micronutrient analysis of leaves. Okay. So, next, second application in LIBS for industry. In the nuclear energy industry, LIBS can work far away from nuclear waste or reactor using standoff configuration or with the fiber optic probes to avoid dangerous radiation levels. Second, in the metallurgical industry, LIBS can analyze the alloy composition in production line or detect impurities in other production sector, such as automotive industry. So the third one is, it is also useful in industry to detect toxic product like heavy metal in industrial waste. Okay, so the last one is analysis and detection of impurities. In solar cell can be useful tools to improve the manufacturing process or to achieve high efficiency solar panels. So it is also very useful in industry for detecting many radiation, like radiation, heavy metal. Are you guys still here?
Yeah.
Yes.
Yes.
Okay, so next we move to the next slide. Okay, so the third one is LIBS and geological sample. Okay, so the first one is analysis of some kinds of mineral is possible using LIBS, in particular of soil and geological sample in situ. The second one is LIBS analysis can detect trace of toxic material in soil, rocks or water without sample preparation and in the natural environment of the sample. Next is LIBS also useful in wide range of environmental conditions and with different atmosphere from air to vacuum. Okay, so actually this feature coupled with the capability to analyze soil sample and the possibility to build the portable setup enables the possibility to work in the space. Okay. So LIBS also very useful to help in geological sample. Okay, so the next application in LIBS is in cultural heritage. So the first one is LIBS is a very attractive technique for characterization and conservation of archaeological sample, artworks, and other important materials. The chemical composition extract from LIBS analysis give archaeologists additional information to better understand our history. So, can help. It can help the. It can help to have the better understand in cultural heritage or in our last history. Okay, so the last one is it is very important assets such as physics, stone, ceramic, metallic, artifact, woods, and pen artworks, among others. So it is also been analyzed by LIBS. Okay, so next, okay, the last application in LIBS is in environmental monitoring. So the first one is LIBS seems suitable in situ and real-time technique to determine nutrient distribution in soil. Second is LIBS focus on investigation of metal accumulation in vegetal tissues. Vegetal tissues, we can know to understand, easy to understand, like leaf, leaf tissues. Okay. So the
Sorry, Haida.
LIBS. Yeah.
What is vegetal tissue just now?
And like leaf. Is it
Leaf.
Oh,
leaf?
leaf.
The green,
Okay.
the plant.
Oh, okay,
The
okay.
Plant.
Okay, okay. Leaves.
Ah,
Okay. Let's proceed.
okay, sorry. Okay, so the last is LIBS is particularly interesting for on-site and remote monitoring of the concentration of toxic metal in liquid environmental sample. So it is, for example, wastewater from industrial plants and in seawater. So LIBS it is very useful for monitoring of the concentration of toxic metal that from waste material, like that.
Okay.
So, okay. So let's move to the limitation of laser induced breakdown spectroscopy. So firstly, there are significant shot-to-shot variation in intensity. So this is because of largely because of the laser doesn't attract with the sample in the exactly same manner from every laser pulse. So this is often overcome by averaging many spectra of the same material. The second one is elemental analysis using an invariant or multivariate calibration does not yield the accuracy or precision of more traditional techniques such as ICP, MS, or SRF. So before this, maybe there are traditional technique that use before the LIBS, such as ICP or so if the traditional. So finally, as with any spectroscopy produced by an instrument, I need to that instrument. And the same sample analyzed on the similar instrument will be slightly different. Okay, so this is when we using LIBS spectra to do profiling. This instrument differences are sufficiently large to prevent the combination of data. Are you still here?
Yeah. Yeah, Ida.
Clear?
Yes.
Yeah.
Can you hear me?
Aida, I can see your slide.
Yeah.
Can hear? Oh, okay.
I can see.
Maybe
Okay,
my
yes.
internet. You can see?
Yes.
Yeah.
Can you repeat that point just
Sorry.
now? Okay, it's okay.
Oh, last point. Okay. Okay. I repeat again. My last point. For this last limitation in LIBS. So when using an IBS spectra to do the study, this instrument difference are sufficiently large and to prevent combination from instrument. Okay, are you clear?
Haida, your sound's not clear. But it's okay.
Yeah.
Proceed.
Okay. Sorry, my conclusion.
Conclusion?
Can you see my slide?
No.
Yes.
Can you see my slide? Okay.
Okay,
Okay.
yes.
So conclusion. As a conclusion, in the form of atomic emission spectroscopy, LIBS is typically a multi-elemental method of analysis. Different atomic needs, LIBS require only a single operation for preparation and excitation of all sample components. So this property confers to LIBS an unprecedented performance in terms of sampling and analysis capability. And lastly, LIBS is also useful spectrochemical technique that can provide chemical analysis in situ without sample preparation, which can be used in a wide range of environments. Are you still here?
Yeah.
Yes, we are here.
I'm very worried. Okay. Let me. Okay, so that's all for the conclusion. Okay, so lastly, this is our reference for all our information that we search. There are thanks for together the reference. You can see, right, isn't it?
Yes.
Yeah.
I can see.
Okay, so I think that's all from us, from our groups. Okay, anything you want to
Okay.
ask or you want to add on?
Okay.
Okay.
Anyone?
Okay, everyone, thank you
Okay,
so
thank
much.
you.
So,
Uh,
this slide I'm gonna be uploading at the Putra Blast.
or YouTube, is it?
Yes.
On YouTube. So don't
Okay.
forget to watch.
Okay, guys. Thank you,
Okay,
guys.
guys. Thank you, guys. Okay, thank you. Bye bye.